Hello everyone, my name is Emma Gerritsen. I'm a PhD student at Radboud University Nijmegen, the Netherlands, and I'll be presenting my work Entity-Aware Transformers for Entity Search, which I did together with my supervisors Faegheh, Hasibi and Arjen de Vries. So, language models as BERT learn rich contextual information and are known to capture much of the world knowledge. This is why they perform well on closed-down mass prediction tests, such as the capital city of the Netherlands is, and then it will predict Amsterdam on the mask. However, they cannot capture sparse world facts, and they fail to perform complex reasoning on these. Many complex queries users have are on entities. For example, the second highest mountain in the world has as answer the entity K2. These queries need information of the knowledge graph, which BERT currently lacks. That is why in this work we try to bridge the gap between the language models and knowledge graph for information retrieval. We introduce our model EMBERT, which is entity monobert. We focus on entity retrieval in this work, which are queries best answered by an entity from a knowledge graph. However, few problems remain for this task. We have limited training data on entity retrieval. The known datasets for this are fairly small, and BERT fine-tuning is known to be noisy with few examples. This leads us to the following research question. Can an entity-enriched BERT-based retrieval model improve the performance of entity retrieval? When and which queries are helped by the BERT model? Why does the emBERT model work, and what does it learn during the fine-tuning stage? And last, how does our entity-enriched BERT-based model perform on other ranking tasks? Let's explain our method. To combine the BERT embeddings and entity embeddings, we use Wikipedia-to-Vec. This method is an extension of Word2Vec, where it does not only embed words, but also entities. It does this by extending the skipgram model to also predict entities based on the neighborhood of those entities, and predict an anchor text based on an entity. With this, we get embeddings of words and entities in the same vector space. Now we have embeddings of words and entities in the same vector space. We can use these words to compute a mapping from the Wikipedia-to-Vec embeddings to the BERT embeddings. We do this by taking all the vectors which are both in Wikipedia-to-Vec and BERT and computing a matrix W such that the vector in Wikipedia-to-Vec times W is as close as possible to that vector in BERT. When we have optimized for this matrix W, we can then use this to map embeddings of entities in Wikipedia-to-Vec into the native BERT input space, thus giving us a way to represent our entities in our BERT input. After we find this W, we can now use this to perform entity re-ranking. We will take the query and the short abstract of the entity, both annotated with entities. The normal text is tokenized as normally in the BERT tokenizer, and all the entities signified with the entity preamble, and here noted as yellow, will be then first looked up through the Wikipedia-to-Vec embeddings and then mapped onto the BERT input space with the eBERT method as said before. Using this, we can use queries annotated with entities and also the abstract of the queries annotated with entities to perform our retrieval. We perform this task on DBpedia Entity v2, which is an entity retrieval dataset, but it's very small, having only 467 queries. We look at the following four models. First is the ModelBERT first stage, which is the generally available model fine-tuned on MS Marco. Next we have ModelBERT fine-tuned for one epoch on the train faults of DBpedia entity. Next we have EMBERT first stage, which is fine-tuned on MS Marco but annotated. And next we have the fine-tuned for one epoch on train faults of DBpedia annotated with entities. So the ModelBERT and EMBERT models, the corresponding ones, are comparable in the amount of training data. Let's look at the results. So, we see that, as expected, there is a drop in mono-BERT due to the instabilities of few sample fine-tuning in BERT. We see that for the NCG at 100 specifically, there is a significant drop in the results. However, for EM-BERT, there is a significant increase in the scores, with the same amount of fine-tuning as was happening with the mono-BERT model. We see that the largest amount of this improvement is for list search and quad queries, which are queries looking for a list of entities with a certain property, and natural language queries, complex natural language queries. These two subsets of queries are among the most difficult of the DBpedia entity v2 dataset. So to summarize, EM-BERT improves after short fine-tuning and mono-BERT decreases. This decrease of mono-BERT is known in the literature to happen. EM-BERT works the best on natural language queries and queries looking for lists with a certain property. So to answer our first research question, can an entity-enriched BERT-based retrieval model improve the performance of entity retrieval? We see that this happens, and especially does very well on those natural language queries and the queries looking for a list of entities. So let's perform some analysis to see what's going on in this model. First, we wonder if the rarity or the difficulty of the entities annotated in the queries had anything to do with the performance of this model. For that, we divide the queries into 4 categories depending on the most rare or difficult entity annotated in this query. The first category are entities which can be tokenized by the regular BERT tokenizer with just 1 token. These are very common entities such as France. Next, we have entities which are tokenized into multiple tokens but without breaking these tokens into pieces. This is common with names such as Joko. Next, we have entities which are broken off with 1 piece. And last, we have entities broken off into multiple pieces. Our hypothesis is the more an entity is broken off, the less it's seen during training, and thus the more difficult it is for the regular BERT model to get high results on these queries. And we can already see that in the graph on the right, that the best performing query categories, as we saw before, so the list search and quad queries, they have a relative high amount of these complicated entities in their queries. And if we look then at the results, we see that indeed the largest improvement on score is for these categories of less popular entities, so the ones which are broken off into at least 1 or multiple pieces. So that answers our second research question: which queries are helped the most by the EM-BERT model? The queries with uncommon linked entities get helped the most. Next, we look how the information of the Wikipedia TVEC embeddings is kept in the BERT layer. If we look at the last layer of the BERT model, if we compare the embeddings of the entities versus the mentions, so the regular BERT token mentions of those entities, and we map them with UMAP, we see that on the right, these are the mention embeddings, and the dots in the scatter plot represent entities relevant to the same query. We see that on the left, these mentions cluster together much more coherent than on the right, where this is much less coherent. So we can see with this that the entity information of these embeddings is kept until the last layer of the BERT model. If we look at the attention which these entities get in the BERT model, we see that the entities get very high attention in the BERT model, especially compared to the passages and queries which are not annotated with entities. We see that these entities get a relatively high amount of attention. Next, we'll look at some examples. For example, give me all the movies directed by Francis Ford Coppola. There are many people in the movie industry with that last name, and we see that for BERT, it gives emphasis on this last name, and then we'll retrieve many movies directed by other people in the Coppola family. However, emBERT will match on the full entity and will retrieve actual documents, actual movies directed by Francis Ford Coppola. For the query, give me all capitals of the countries in Africa, we see that BERT gives mainly overview pages, while emBERT gives specific pages. So while BERT gives pages like all dependencies in Africa, emBERT will give a specific page like Dakar, which is an actual capital city in Africa. So to answer our third research question, why does the emBERT model work and what does it learn during the fine-tuning stage? The entity relations remain up until the last layer of the BERT model, and the entity embeddings get high attention by the model. Last, we also perform some tasks on MS Marco. This is not an entity-oriented dataset, but still, if we annotate the queries with entities, we see that on average we have 0.34 linked entities per query. However, there is no significant difference using emBERT or ModelBERT, and also not if you specify the subset of queries with only linked entities. This is because a query, when it has a linked entity, does not have to be entity-oriented. For example, what is the opening time of Madrid City Hall? This information need is too specific to be found on the entity page of Madrid. So to answer our fourth research question, how does our entity-enriched BERT-based model perform on other ranking tags? This architecture is not suited for passage retrieval, leading to no significant improvements. So, to conclude, transformers for entity retrieval can be helped by entity embeddings, and it helps with few example fine-tuning. The complex queries looking for entities are helped the most, and especially for rare entities. Entity information is kept up until the last layer of BERT, and to apply this research to non-entity oriented retrieval systems, there's more research needed. Thank you for listening. If you have any questions, you can email me at the email address listed here.